Hello students, welcome to online biology class. Today we are going to cover about day 7 of unit 2. Every day you will be attending the online class and you will be completing the homework for that day. Make sure that you have your textbook and notebook all the times when you are attending the online class. For any queries, you will be having a synchronizer section where you can interact and clarify your doubts. Children, in the last classes, we have dealt about breathing and respiration. I have made you a very clear-cut idea about respiration, that it involves 5 major steps. That means respiration is being carried in 5 steps or 5 events. Let us recall the events of respiration. The first event of respiration is breathing. The second event of respiration is gases exchange at lung level. The third event is transport of gas by blood. And the fourth event is gases exchange at tissue level. And the fifth event is cellular respiration. In the past classes, we have studied about all the events which are being done in the first 4 stages or first 4 steps. Now, so today let me announce my topic as cellular respiration, the 5th event, which is nothing but cellular respiration. And the aim of today's class is to understand how energy is finally liberated. Children, in the first class itself, we have studied that food is a main source for each and every organism, that may be unicellular or that may be multicellular. The reason, because food provides energy and this energy is needed for all the organisms to carry out their life process. So, you shouldn't think that I am standing quiet, I am not doing any work, but most of the physiological work is being done in your body and complete that requires energy. So, this energy, what we are speaking in biology, is exactly different from the energy what you speak in your physics. So in your physics you say that energy is nothing but there should be some displacement, right? Energy means there should be force should be applied and the body should be moving, that means there should be displacement, something like that. But here energy is completely different. Now even I have told you that food directly it cannot provide the energy. Yes, right? So now the main objective of today's class is to know how this energy is being liberated. So now the food cannot directly it cannot provide the energy. The food is being procured by the organism. As soon as the food material is being procured, the food is being broken down into small particles called as nutrients. Of course, the nutrients may be any of the components. That may be glucose, that may be amino acids, or that may be fatty acids. Anything, glucose, amino acids, or fatty acids. But the main nutrients what provides easily the energy out is glucose. Now any of that nutrients is being supplied into the cells, right? Food is being taken, food materials are being broken down into nutrients and these nutrients are being supplied into the cells, right? So we have seen in the pathway of air, right? Air enters into the nostrils, from there from one to another, finally it reaches into the lungs. From lungs, then it enters into the blood. From blood, so this oxygen, the gas is being supplied into the cells. I told you oxygen binding proteins are going to be present and these oxygen binding proteins, they absorb the oxygen into the cells. And I told you the oxygen concentration will be very low, so therefore from higher concentration to lower concentration region, oxygen is being diffused into the cells. So now within the cells, so the cells has got nutrients, the cells has got oxygen. Now within the cells, oxidation of food material or oxidation of nutrients is going to take place. Because of this oxidation of nutrients, that means all the nutrients are being broken down and energy is being liberated. And this energy is being utilized for various activities what we are going to do or what we are going to perform in our day-to-day life. So here, priorly, the nutrients before they are being supplied into the cells, nutrients were being present in the blood vessels, and even oxygen is also present in the blood vessels. But in the blood vessels, this process couldn't take place. That means what, oxidation of food materials couldn't take place. Only oxidation of food materials will be taking place in all the cells other than the blood vessels. Directly in the blood vessels that doesn't take place. Now, in later on I will be saying you why this doesn't take place directly in the blood vessels. Right? It will be very easy. If the food materials are being, that means what, nutrients are being oxidized directly in the blood vessels and directly the energy is being distributed, that would be very better, right? But that doesn't take place. Now, what are the reasons? I will be saying you in upcoming session, in upcoming of the topic. Then, so here I told you nutrients are being oxidized, they are being broken down and energy is being liberated. Along with this energy, carbon dioxide is also being liberated. That means what, carbon dioxide is being evolved. Now, the carbon dioxide percentage inside the cells is more comparing to the external environment, that is nothing but in the blood vessels. So therefore, diffusion of carbon dioxide from the cells, it enters into the blood vessels. There, the carbon dioxide dissolves in the blood plasma. Most of them it is going to be present in the form of bicarbonate. A very few amount of carbon dioxide is being evolved from our lungs in the process of exhalation. This is what we have discussed in yesterday's class, right? So now here what is happening here? So energy is being liberated and carbon dioxide is being evolved. Now this process is happening inside the cells, within the cells. Therefore, we call this process as cellular respiration. What do we call? Cellular respiration. What is cellular respiration? The breaking down of nutrients and the liberation of energy which takes place inside the cells or within the cells is called as cellular respiration. But this cellular respiration, you can't think that, you can't imagine that this is a single step reaction. It directly doesn't undergo the nutrients. Okay, the glucose has come or amino acids has come or fatty acids has come into the cells. Directly they will not break and directly energy is not being liberated. So in a series of manner, step by step, so the nutrients are being broken down. In the same way, at particular steps, right, some amount of energy is being liberated. All the energy is not being liberated at the time. And complete these chemical reactions, what are being taking place here, right? So that means here I have told you that energy is being liberated by breaking down of nutrients. That means we need to understand that energy is being stored in these chemical substances. The food material, the nutrients are nothing but the chemical substances. Now, within these chemical substances, glucose or amino acids or fatty acids, energy is being fixed or trapped in the form of chemical bonds. Now, during these reactions, these chemical bonds are going to be broken down and the energy which is being fixed in that is being released. So therefore, all these things are chemical reactions. And these reactions, they depend on some of the enzymes and hormones whatever being present in our cells. So these enzymes are present inside the cells, they are not being present in the blood vessels. So therefore, this cellular respiration takes place only in the cells. They cannot take place in the blood vessels, because in the blood, so these enzymes which are required for breakdown of these nutrients are not available. They are only available inside the cells. So now where this cellular respiration is going to take place, now let us see. Like the cellular, as I already told you, respiration commonly takes place both in prokaryotes, that means what, in all the organisms. So that means it takes place even in prokaryotes as well as eukaryotes. Prokaryotes, I hope you have studied about the words, terminology of prokaryote and eukaryote in your 9th class. The word prokaryote, pro means primitive, karyon means nucleus. The organisms which are with a primitive nucleus. That means what? The nucleus doesn't have any nuclear membrane. Right? So that means what it is in the form of the nuclear material is being dissolved in the cytoplasm itself. Such cells, they are called as prokaryotes. And so in case of prokaryotes, this cellular respiration takes place in cytoplasm. The site of cellular respiration in prokaryote is cytoplasm. Whereas eukaryotes, eu means true, karyon means nucleus. Organisms which are with the true nucleus, we call them as eukaryotes. That means what? Nuclear membrane is being present, nuclear material is being present in the nucleus. That is not being present in the cytoplasm. Right? So such organisms are called as eukaryotes, and in case of eukaryotes, so the site for cellular respiration is cytoplasm and mitochondria. I hope children you know about the mitochondria, right? What is mitochondria actually? Mitochondria is a cell organelle. Yes? So it is present in the eukaryotes. You know, both in case of plant cells as well as in animal cells it is going to be present. So you have studied mitochondria of various shapes. They may be oval, they may be circular, they may be club shaped, they may be rod shaped, but mostly the mitochondria are going to be rod shaped. So when you are going to cut the mitochondria, and when you are going to see, you can see one, if this is the outer membrane and this is the inner membrane. And you can see the outer membrane is continuous, it is smooth, but whereas inner membrane it is being folded into several folds, and these are called as cristae. Right? And so complete this is called as matrix, and inside the matrix it has its own DNA, it has some of the enzymes, it has got some of the F1 particles. We call it as F1 particles. Now, in this mitochondria and in the cytoplasm of eukaryote, cellular respiration takes place. Right? So, now till here what we have discussed, so the process of breaking down of nutrients and liberation of energy takes place inside the cells. Therefore, we call it as cellular respiration. And the site for this cellular respiration in case of prokaryotes is cytoplasm, whereas in case of eukaryotes is cytoplasm and mitochondria. Right? So now this is a common process we have discussed. Right? So if this process of breakdown of nutrients, it can take place in presence of oxygen, or this can even take place in absence of oxygen also. Now, if this process takes place in presence of oxygen, then we call it as aerobic respiration. The process of breakdown of nutrients in the presence of oxygen, we call it as aerobic respiration. This aerobic respiration takes place in almost all the living cells. That may be plant, that may be animal, whatever it is. In this, glucose molecule is being oxidized and it is being broken down to carbon dioxide, water, and energy is being liberated. So, in case of absence of oxygen also, the nutrients are being broken down. Such process is called as anaerobic respiration. This anaerobic respiration even takes place in human cells also, especially in the muscular cells, human muscle cells, and in bacteria. In human muscle cells and bacteria, this glucose is going to be broken down to produce lactic acid, and energy is going to be liberated. Lactic acid and energy is being liberated. Whereas in certain other eukaryotes like yeast, this glucose is being broken down for the production of alcohol, and along with that carbon dioxide, water and energy is being liberated. Now that process of anaerobic respiration where alcohol is being produced, we call it as fermentation. Actually, yeast produces two types of enzymes which are called as zymase and invertase. They are responsible in production of alcohol. And so that particular process we are going to call it as fermentation. So like this, the end products of anaerobic respiration are lactic acid or alcohol. It depends upon. So that means we are very clear the nutrients can be broken down in presence of oxygen or in absence of oxygen. If it is going to take place in presence of oxygen, we call them as aerobic respiration. If it is taking place in absence of oxygen, we call them as anaerobic respiration. The end products of aerobic respiration are carbon dioxide, water and energy. Whereas the end products of anaerobic respiration, that may be lactic acid or alcohol, carbon dioxide, water and energy. Where do this aerobic respiration takes place? In all plant and animal cells. Where do this anaerobic respiration takes place? In human muscular cells, bacteria, yeast, etc. And the energy which is produced in anaerobic respiration, this is very less, whereas the energy which is being produced during aerobic respiration is more. The energy which is produced in anaerobic respiration is 1/10 of the energy which is produced during aerobic respiration. That means very little amount of energy is being released here. Now whatever the energy which is being produced, that energy is being taken by adenosine diphosphate. A means adenosine, and you can look after two phosphates are being present. So, and this adenosine diphosphate, by using this energy, combines with inorganic phosphate, and it transforms into ATP, adenosine triphosphate. You can look after three phosphate molecules are being present, and this energy is being stored in the terminal phosphate. And whenever the cell requires the energy, this ATP is being broken down to ADP. ATP is being broken down to ADP, and energy is being liberated. That energy which is being stored in the terminal phosphate, that is being liberated, and almost one ATP molecule, it will produce 7,200 calories of energy. How much energy? 7,200 calories of energy is going to be produced, and this energy is being utilized for various metabolic activities. You may sit, you may stand, whatever it is you require energy, and for that energy this ATP molecules are going to be produced. And once again ADP molecules, when energy is there, they convert into ATP. This is a cyclic process, and these ADP molecules, they are being stored in mitochondria. Therefore, so we call ATP as energy currency of the cell. Since they are stored in the mitochondria, we call they are the powerhouses of the cell. Mitochondria are called as powerhouses of the cell for that. Now, overall I could say, so during this respiration, actually it takes place in cytoplasm. You can look after this is the stage which takes place in cytoplasm. And if it is prokaryotic cell complete, this also takes place in cytoplasm, and this takes place in mitochondria. Sorry, this takes place in mitochondria, and this process is taking place in cytoplasm. So what happens here? One molecule of glucose is going to be broken down into two molecules of pyruvate, or otherwise we call it as pyruvic acid. One molecule of glucose, it is a 6-carbon compound. It is being broken down into two molecules of 3-carbon compound, which is called as pyruvic acid. Now this process is called as glycolysis. This is common for both aerobic respiration as well as anaerobic respiration. That means till here, so it doesn't use any oxygen molecules. Right? So now the fate of this pyruvate depends upon the presence of oxygen or absence of oxygen. If oxygen is being present, pyruvate enters into this mitochondria, right? So then it undergoes the further process, and so during this, so the new pyruvate is being completely broken down into carbon dioxide, water, and liberating the energy. Whereas in case of absence of oxygen, so you can look after here, so that is in the anaerobic respiration, or when there is very little amount of oxygen is being available. So this is being broken down. Pyruvate is being converted into lactic acid and energy is being produced. And so if in case of yeast, as I have already told you, it may be converted into ethanol. Along with ethanol, carbon dioxide and energy is being produced. So that means to complete this process also takes place in cytoplasm only. In case of prokaryotic cells, it takes place only in cytoplasm, everything. Then in case of eukaryotic cell, it takes place in cytoplasm as well as it takes place in case of mitochondria. So like this, in case of aerobic respiration, 38 ATP molecules are going to be produced from one glucose molecule, whereas only 2 ATP molecules are going to be produced, so from anaerobic respiration, right? So in case of ethanol, that is nothing but it is an alcohol which is being manufactured on a large scale in distilleries, right? So this is about this is because of fermentation, as I have already told you about this. So this is about cellular respiration and how energy is being made available by breakdown of nutrients. And children, today's your home assessment is write down the fate of glucose in presence and absence of oxygen, right? And the one more question what you are going to have, so is write down the differences between aerobic respiration and anaerobic respiration. The first question given for you is write down the fate of glucose in presence and absence of oxygen. So you can even do that in the form of flowchart, no problem. Then the second question what I am going to give you is write down about the differences between aerobic and anaerobic respiration. Thank you children, have a nice day.